This is the malware fingerprinting track for you in the audience, just in case make sure you're in the right place. I have the privilege today of introducing Patrick Thomas. And I say privilege because this is one of the sessions I was going to come to regardless of whether I was proctoring or not. So glad to see you guys could make it. Today's presentation is the white elephant. BlindElephant. The BlindElephant, excuse me. You want to give me the whole title, or you just want to go ahead? I'll just turn it over to Patrick, and I'll let him introduce it for you.
I totally should have seen that coming when I named something BlindElephant. It's going to be white elephant in everyone's mind, so I'll just get used to that. Okay, as you said, we're talking about, how am I doing volume-wise? Okay, cool. Web application fingerprinting. Talk a little bit about web applications, some of the interesting challenges they have for security, some of the ways in which we need to think about web applications differently, and then talk a little bit about the existing fingerprinting approaches that are out there. Talk about some of the problems that we have with that, some of the reasons why that didn't serve some of our needs, and then the static file approach, take you through the details of how that's done, and then once we actually had a tool that does that, we said, all right, let's go out and use this tool. Let's make some observations of the entire net and draw some conclusions about how people are actually doing with web application security. If we have time at the end, we'll do some Q&A, and hopefully in there we'll also be able to actually run this thing on some web apps that you guys are running, see if you're up to date. Well-known web applications, that's what this talk is about. There are lots and lots of custom web applications out there, people doing all sorts of new stuff in-house, little one-off web apps. We're not talking about those. We're talking about sort of well-known, off-the-shelf, whether open source or commercial web applications that are used in all of these things. People expect web apps to be blogging, to be content management systems, to be maybe e-commerce, all of those things, but web apps are very much tons of other technology. Emails, and say squirrel mail or any of those, PHP MyAdmin, many of these things that used to be sort of large, dedicated enterprise applications or thick client or desktop applications, for all the reasons that we take things to the web, are becoming web apps. So when we talk about web application security, it's not just simple stuff like your company's marketing blog. Real serious infrastructure type stuff is very much managed in web applications right now. The typical slide that everyone needs. These are some of the well-known web applications we support in BlindElephant currently, most of the ones on this list. I'm sure you guys use these things very much on a daily basis. So special challenges. We were talking about how are web apps different than some other stuff. They're remotely accessible by nature. That's the big thing. Any exploit that you have in a web application is, by default, a remote vulnerability. And if it's on your intranet, it's typically available to your full intranet. If it's on the internet, it's available to the entire internet. Lots of attack surface. This is an interesting one. You've got all the direct attacks, the injection attacks, stuff that comes in from the front end. You've also got indirect attacks, cross-site scripting, CSRF, all of those things that you're going to bounce off of a legitimate user. So lots of things going on in web apps, lots of functionality being added, quick development cycles. Also, these things are phenomenally easy to set up. Many of them will say you've got your 5-minute install or your one-click install, those sort of things that power users say, hey, cool, one less thing I need to worry about. But some of the users who wouldn't necessarily go and install a web app or set up a new application will say, hey, this looks really easy, or my friend told me this was really easy, go and set it up. And they're not necessarily going to go through the channels that they might used to if something was really hard. If you think it's going to be a painful several-hour process, you're going to set it over to IT. If you think you can just spin up a database and a web app in a few minutes, these are the kind of things that fly under the radar. Fast release cycle, we talked about that for all the reasons that we like developing web apps. They have that other side from the administering, from the maintenance, from the security perspective. This one, some people may disagree. I think it's actually true. Exploits are simpler to comprehend and therefore also simpler to create, to propagate, to execute. Here's 2 examples of actual complete working exploits. These are known published ones. A WordPress admin password reset and a Joomla, I think it's a file disclosure. And executable via or exploitable via wget. You don't need IDA Pro, you don't need any of these deeper tools that takes a little bit more domain knowledge to understanding these exploits. So there's a lot going on in web application security. And of course, everything the WAF vendors are saying, I won't reiterate all of that. Whoops. There you go. Web application scanning, lots of cool problems going on in there, lots of hard problems, lots of really interesting research. We're very much not doing that. This is web app fingerprinting. We're saying if it's a known off-the-shelf web application and you've got vendor-published vulnerabilities or community-published vulnerabilities, then it's very much like traditional vulnerability management, where if you're running XPSP2, we know you're vulnerable to all of these different things, and that's actionable. That's something that you care about, whether you are a system administrator or a pen tester or an auditor or something like that, or whether you're building this into tools. So knowing the version is good enough to infer these well-known vulnerabilities. It's definitely not as sexy as WAS, but this works, and I'm going to talk a little bit about why it works. So discovering the app and the version is fingerprinting. Quick theory of fingerprinting. We don't need to dive too deeply into this, but we're looking for some characteristic that identifies an individual. Now, how we define individual depends what we're doing. If we're doing criminology, then it's the actual fingerprint. This thing identifies me differently from this gentleman in the front row who loaned me a power cord. If it's, for example, an operating system or an HTTP server, a lot of the logic on that relies on sending slightly malformed packets, maybe several different aspects of the packet that don't conform, and seeing which errors come back. And often you need to try a whole bunch of different things, and then the intersection of those can give you more information than any one. So OS and HTTP fingerprinting are very well-known standard tools in the toolkit. What we're doing is providing that technology, that tool in your toolkit at the application layer. Some existing approaches, by and large, are regular expressions. Lots of tools out there that do some variant on load the home page, look for some string that we've computed. Works reasonably well. Doesn't fit our purpose for a couple of reasons. One of them is there is human effort involved in finding each of those strings and supporting each of those applications. If a new version comes out that provides different strings, say included JavaScript functions or something in the comments or a meta header, any of those kind of things, a human has to go through, take a few examples, look at it, make a judgment call, and write a regex. And it's only a few minutes, say, per version or per new application. But with the explosion of many different web applications times many different versions, in many cases times many different plugins, and then again times versions of those plugins, we need something that will scale very, very well. If there's any human judgment in the loop, we cannot scale with this. So we're looking for something that takes human judgment out of the loop on all of this. Also, decent hardening. If somebody is going in and saying, hey, I don't want to say that I'm powered by WordPress or powered by PHP-BB. I want to take that out. I don't want to say that it's proudly running version 1.5. I'm going to make that go away out of the source code. There are lots of guides for doing that. Many applications are sort of getting on the bandwagon and saying, we're going to go ahead and provide a little checkbox that says strip all identifying information. And for applications that are not doing that, there are people coming in, third parties, and providing plugins that will do that. You can say, install this plugin and make all your identifying information go away. And then finally, though people aren't doing this as much, they're very easy to lie to. If you want to claim to be a completely different version than you actually are, you can just simply put that into the code and go with it. Some fingerprinters like that down here. These are not bad tools. These are very useful tools, but they don't meet some of our needs for those reasons. Slightly more advanced tools, we see a little bit of advancement in usually one area. Securi were the first people to talk about this static file fingerprinting. I saw it on a blog entry of theirs a while ago. They were sort of doing a proof of concept. It was got some good results, but it was fairly manual. It didn't pin things down to a particular specific version, so it was a little bit less actionable. What Web is doing a whole lot more, is gathering an astonishing amount more data, but they end up pulling down so much data that's really not useful for scanning large numbers of machines or not setting off every IDS in the country. All right, so setting out some goals for any fingerprinter, web app fingerprinter in particular. We want it to be very generic. We want to run the same code for every single app that we come across, for every single plugin. We want this to be very data-driven. All the logic is in the data. We want it to be fast. My goal was, you shouldn't have to go get a cup of coffee while this thing's running. Ideally, you shouldn't even have to reach for your coffee. We'll see how that goes. We want it to be low resource usage. You shouldn't abuse the machine on the remote end, and you shouldn't have to have a gargantuan machine on your end. Accurate, low false positives, low false negatives. These are the things that make a tool actually useful. Obviously resistant to that hardening and the banner removal that is slowly starting to happen in web applications that was used by the regexes. And then here, I am just one person. I'm trying to support a lot of web apps, so I need to design a system that would be very, very easy to support new apps. And then if I'm asking people outside to help me with that, I want to make it very, very easy for them to help support a new app that maybe they only have access to. All right. So it's called BlindElephant, and it comes from this old Indian fable. Hasn't anybody heard this Indian fable? A couple of hands? Okay. I think this is really cool. It's it's a parable on the unknowability of truth. A number of blind men or men in a dark room are all touching an elephant and trying to agree amongst themselves what it is. And one of them touches the side of the elephant and says, it's a wall. Another one grabs a leg and says it's a tree, or the trunk and says it's a vine. And they all see sort of this one aspect of the truth, and the sort of cone aspect of it is you can't truly know all of truth. And it's a cool little parable, but it pissed me off, because if they would all just say the things that it could possibly be, very quickly they'd come down to it can't be all of those things together, but it can be this elephant. So, it's a tree or an elephant, it's a spear or an elephant, it's a vine or an elephant. You put those things all together, you intersect those possibilities, and we have an elephant. So that is exactly what is going on in static file fingerprinting. Really no more, no less. So if you keep that in mind, the rest of these slides should make perfect sense. And if you go to look at the code, that's really all that we're doing. Okay, so how do we do this? Preparing the data. Go get every possible version of an app that you can get your hands on. Whether you go to Subversion and check out all the tags, whether they've got a nice archives page and you just right-click and say download everything here, however you want to get those versions, dump them into a directory, unpack them. I've got some scripts for that. And then what we're going to do is we're going to build two tables. The data files on the left, lots of data going on there, lots of files, gigs and gigs. We're going to compress that down to these two things that we actually use to make the decisions about fingerprinting, which end up being a little under a meg, depending on what you're dealing with. So these are very easy to transport. Those are in Subversion, and you can check those out and get them and play with them and see what kind of data is encoded in there. We use these data tables to answer two questions. The first one for the paths table is, what versions will a path give me information on? If I fetch this particular path, /resources /something.css, what versions is that file present in, and what versions does it differ in? Therefore, if I fetch that file, what kind of versions, if I hash that file, will it tell me about? The other side is the versions table, which is the exact same data grouped slightly differently, that if we want to confirm or rule out versions. We've done some fingerprinting, we've got it down to, we think it's version 3.1 or it's version 3.2. Hey, versions table, what's a file that can help break this tie? What's a file that will give me deeper information once I've got a small set of versions? So here it is, a little bit of an eye chart here. Don't need to worry about it too much. Basically, WordPress, every version, */*, all the files. We're going to chew through those and compute hashes on those and send those to the paths table and the versions table. Here's what it looks like. paths table is keyed by file, and the values are hash to version mappings, and the versions table is versions and their file to hash mappings. Currently we're doing MD5. We want to do some sort of deeper, cooler stuff with this, but we've gotten good results with straight up cryptographic hashing so far, so the rest of this stuff is future work. Hopefully we'll get to that. Everyone good so far? Chewing up massive amounts of source input files and producing these two hashes tables, or these two data tables. How many files are we talking about? Got currently 166 versions of WordPress, 32 versions of PHPBB. We're supporting a lot of different versions of these files, of each of these web applications, and many files within there. Got support for a couple of plugins. I'm just doing 2 right now to show that the technology worked. We'll add more later. But you can sort of see that explosion of different artifacts to deal with when we get down to plugins. 1,200 versions of WordPress plugins that we can uniquely identify. So fingerprinting. What we don't want to do is look at all these possible files that could exist on a remote system and fetch them all. That would take forever and hundreds of megabytes and is unreasonable to do. What we want to do is surface a couple of files, 10 or 15 files, that give us lots and lots of information about what's there. So we want to pick files that are present in many versions, because we request it, and if we get a 404, that hasn't helped us. It's helped us a little bit. We know files that, we know it can't be any of the apps that actually contain that. But we want to find files that exist in many versions and also have changed from version to version to version. So you can sort of think logically, things like changelog or what else do we have in here? Changelog, install or update, or any of those sort of user documentation that discuss new functionality. Those will definitely change, and that's no trick to find those. Finding ones that are really obscure is the trick, and that's one of the nice things about having this, again, fully data-driven, no human judgment process going on. So here's some of the candidate files, like for example, for movable type, mt.js, client.js. These are all, again, these static files. We're not looking at any PHP files. We're not looking at any JSP files. Those kinds of interactive files, we don't care about those. Those are all blacklisted out when we start chewing through the source code to produce the data tables. So here are the 15 that if you go to find a movable type machine or a movable type app, these are the ones that it'll get. MediaWiki, obviously documentation, changelog, the heuristics to pick files automatically surface those, and then some slightly less obvious ones, lang, synclang. I don't know that I would have gone looking for that one early on as a very useful file to fetch, but it popped up there. Some of that stuff. So again, just hammering on that all the data is in the code, none of the data is in the operator or the person compiling the tables. So fingerprinting. We've got these cool data tables, and we know what files we want to request from the remote machine, so we go ahead and request them. As each of those goes out, some of them will get 403s or 404s based on little individual strange configurations or stuff that people have done. That's okay. We're fetching a bunch of files. We only care that we get data back on a decent number of them. So here, it didn't come out as large as I was hoping, but got versions, the one file gave us version 201, 202, maybe 304 RC. Something else said 251. We've got these sets of possibilities. Remember the elephant? We intersect them. And what we have with that small area is we have files which there is definite concrete evidence for the existence of that version, but no evidence against it. Okay. So if, for example, if we'd done that and got in this inner circle here, or this sort of inner area was too large, whoops, how's that? This inner area was too large. If it's not useful enough for our purposes, whatever our purposes are, we can turn around and winnow. Remember the versions table that will allow us to confirm or refute the existence of a particular version? So we're going to go ahead and pick some slightly different files, based on what's in the version table. You look up the version that you want to confirm or refute, get out a whole list of files that will give you information on that version, and fetch it, and send a smaller set of requests, and ultimately we're able to narrow it down a bit. Winnowing is turned off by default, but if you turn it on, it tends to reduce your version set by about half, which is pretty nice since the results are reasonably small to begin with. So if you need more accurate data and you're willing to make a few more requests, winnowing is a way to do that, all using the same data that we collected up front. This data also allows us to do application guessing. Using the versions table, we say, hey, surface for me files that exist in every single version that's out there. If not every single version, then 99% of versions, and we'll pick up that other one with an additional file. So we get a very small set of files that darn well should exist in, say, every version of Moodle. I think that's Moodle up there. Is it? Whatever. And so things like the application logo. It's been there since the beginning of time. It hasn't changed. They like it, and it's staying right there in /images logo. All right. So if we're doing app discovery, send those files at it. One of them should come back with a recognized hash, and being it's some version of Joomla, we can turn around and then go ahead and do full-on fingerprinting against, now that we know it's Joomla, we can use the Joomla tables to fingerprint. Okay, supporting a new application is pretty simple. As I said, gather every version you can, dump them in a directory, chew through them, get out 2 tables on the end, and then turn around and say, whatever my new app is, fingerprint using those tables. All right, so this tool is only interesting if it works. Turns out it works pretty well. I'm going to go ahead and fingerprint my boss's website here. We know it's happen to know it's a movable type, so I'm going to plug that in, load up those movable type data files, and start fetching each of these indicator files that we care about. So you see mt.js implies this set of versions, client.js implies this set of versions, and those are pretty large sets of versions, larger than I would like to see. But again, the only thing we care about, as we're going through large sets of versions, is this inner area. As long as that's small, any of the individual files can post back many, many versions, but we can narrow it down. So if we finish this fingerprint, we get out to fingerprinting resulted in any of the 4.2s or the 4.3, either the regular version or the commercial version. Turns out this is 4.23 commercial, so we're doing all right. This has a vulnerability in it, by the way. Sorry. It does plugins too. Again, same logic, same approach going for this. We can say, hey, go to some example site and please guess, and we know it's Drupal, please guess what plugins it has. Chug along for a few seconds and come back and say, here are all the supported plugins. They could also be running other plugins, but they just aren't ones that we support. But this is what we're able to discover. And then turn around and say, we care about what version the IMCE plugin is. OK, cool. We'll fingerprint that and came out with its Drupal 6.x version 1.3 of the plugin. So there you go. Tool kind of does its job. Anybody run any of these well-known web apps? Any of Joomla or Drupal or WordPress, PHP, BB, that kind of stuff? You want to be a guinea pig in the white?
Sure.
Okie dokie. Oh, it's Windows. We can't do that. All right. What do you got? Somebody?
ARP renewal.
Gotcha. artrenewal.org. And should I guess what you're running, or do you want to tell me?
Yes.
That's not even a question, all right. Okay, so what this is doing is going through all of those data files that I told you about for every supported web application and finding out what files are likely to give us good information on what he's running there. So it's going to try and send maybe 2 to 3, 2 to 4 requests for each supported app to see if maybe it's running there. So I told you I would hopefully not send you for a cup of coffee on the actual fingerprinting. Guessing does take a little bit longer, so I've made a liar out of myself. Unlikely, actually. I had to explain that to our legal counsel a while ago when we got a cease and desist. But no, this is actually behaving very, very much like a web browser in terms of the kind of traffic that it's sending, the volume, the speed, the types of requests. All the requests are very well formed. So, yeah, this is just URLlib, HTTPlib. I was banging my head against some of the stuff that Python allows there. Ooh. The demo gods do not smile on me. You want to tell me what version it is? Or do you want to tell me what app it is? Is that where your blog is? Or is it like /blog? That could make a difference. Let's try it out that way. And let me load this up just to make sure I'm actually hitting something live. artrenewal.org. I would have expected an error if it was, if we couldn't get there at all. Okay, here, so very cool looking blog here. A little free advertisement there, a little nudity.
I like movies.
All right. Man, I hope this works. No, that's not. Yay. All right, I will figure out. And are you hosting this yourself? All right. I'm making a fool out of myself. All right, to recover a little bit of face here, I'll go ahead and do a live fingerprint of that one I showed you just a moment. What's that? Shouldn't. Well, if is there a redirect there? Hang on. I don't want to burn too much time on this. I should have known better than to tempt the demo gods. That's all right. So this is the one that you just saw on the slides, but it's a little bit slow over here. I think I'm running over a VPN actually. So here's each of those version sets coming up. And this could be multi-threaded. Right now it isn't. We could make all these requests in parallel. So there's a lot of speed to be gained, but it does the job right now. Okay, so there it is. It is running live. Let me go ahead and get through what we have, and then if we get closer to the end, I'll take a couple of more shots. There we go. Okay. Okay, we've got this toy. We assume that it works. Evidence to the contrary notwithstanding. Did a whole bunch of targeted scans based on Shodan to say, all right, go get a whole bunch of things that we're pretty darn sure are WordPress, hit them, get versions, try and shake out some bugs. A bunch of scans on that. John helped me out a lot. Is he here? I told you I owe you a beer. All right, I still owe him the beer, but he's not here. Okay. Then got a dump of 87 million .com domains. And said, okay, let's go and do app guessing and then fingerprinting on all of those. So discover if there is a supported app there, and then go ahead and fingerprint it and see what version's there, and take the results from that and see what interesting stuff cropped up. Okay. So quick word on these pictures you're going to see. You notice that there is, at the top of there's 0.8 of a host. So these are version distribution of some app that I'm going to talk about. Here are the most recent versions here, your latest betas and release candidates, all the way down to stuff that's very, very old. Depending on how old the project is, several years old or 10 years old. And then across going, the bars represent how many hosts we found running those versions. So remember, we're talking about sets of possibilities. If we fingerprinted host 1, and got back, we can't pin it down specifically, but we know that it's running one of these 3 versions. Then each of those columns gets 0.33. We go and fingerprint host 2, and we say the possible versions are 1.5 or 2.0. Then we do 1 over n to that column, and then finally host 3. We actually pin it down to a specific version, so the full 1.0 or 1 over 1 to that column. So here's basically the X-ray of that previous chart. So we are representing the fact that we can only infer sort of sets of possibilities, but it lets us put all the data on the chart and not misrepresent anything. So okay, here's what we found: whole bunch of Drupal machines in this version distribution. You'll notice there's kind of this sort of swoop here that it's very few people are running the truly ancient versions, and comes up and then spikes and comes back down to sort of this bell curve type thing within about the last 3 to 8 versions. So keep an eye on that trend. It will show up a lot. Also notice a couple of these little spikes here. They will also show up a lot, and we'll discuss why that is. So here's the distribution of people running Drupal. You can see most are in the 614, 615, 613 range. Drupal has some vulnerabilities. Obviously, we know about them. They publish those. So some % of these people are running a version that is affected by known critical or serious vulnerabilities. Not everyone falls beyond that threshold, obviously. So the question for you guys is, what % of people, these are your random hosts on the internet, are running something that is vulnerable to a remote critical exploit? Raise your hand if you think less than 50%. You guys are realists. Obviously more than 50%. How about if you guys think between 50 and 75? Raise your hand. Couple? Come on. More than 75? There we go. More than 80? Okay. So 70% there. These you can see pretty much any of these people running the old versions are definitely going to be vulnerable. But these people who are kind of here in the middle of the pack in this bell curve, it comes up and bisects right through that bell curve. So if you sort of thought you were running with the pack, you're probably behind. Also notice these couple of spikes. These are hosting providers and package managers that are not providing a version that is up to date enough to keep you away from these critical vulnerabilities. This is, if you grab the slides, the actual vulnerabilities are in there. So anybody running a version less than 6.16 was vulnerable to this. All right, how about Joomla? Less than 50%? Somebody, I heard 90? 90? Nice. That 92% of Joomla users out there are running a version that is affected by this vulnerability or something farther down the line, which is just astonishing to me. And these are well-known published vulnerabilities. Like the vendor has said, here, update your software, here's a fixed version, don't run this stuff anymore. And still 90% of people don't update. I'm not saying anything surprising if I say users don't update. I may be saying something a little more surprising if I say website administrators don't update, but not hugely surprising there. But it's staggering to me how far behind all of these guys are. LifeRay, I'm not going to pick on them, they're too small. MediaWiki? %. At some point, you're just like, the numbers are going to be disappointing, and it goes up. You can see definitely the spikes from the package managers and the hosting providers are right here. So if you're relying on those package managers or those hosting providers to protect you, you're very much not being protected. Well, you may be, but just not soon enough. All right, Moodle. 74%. Movable type, there you go, 91%. And ouch, these guys who were right here on the, thought you were running with a really popular version. As I look at this, I'm trying to sort of figure out why people end up being behind, whether it's the pain of updating or whether they're chasing a particular feature, or in some cases with something like this, plugins may be holding people back. But if you are PHPBB, so this is perhaps a little bit not fair because basically the day that I did the scanning, this was coming out, so people hadn't upgraded to the latest version. But that's a truism of operating machines in the real world. At some point, awful stuff like this is going to happen. But if I go back and scan right now, do you guys really think that this will have moved above the line? No, it's, we'll have a little bit of uptake going along here. There's more research to be done here on coming back a week later, a month later. I haven't done that. I'd like to, but we got time constraints. PHP Nuke, it's a forked project. I'm not going to pick on them. Here's the weird one to me. PHPMyAdmin. If your blog goes down, that's not awful. So maybe you'll risk doing the sort of the change management problems of updating that. Or if your CMS maybe has some issues, you can, if you think the upgrade process might be a little bit hairy, you can do it in the middle of the night. But it seems like if something is critical, if PHPMyAdmin is your database management solution at your work, you get it working and you don't touch it. That's the story that I get from this spikes all over the place of essentially popular versions that people have stayed on. Everybody else had that nice curve that went kind of from here all the way up to here. PHPMyAdmin very, very much not so. What do you guys think? Percentage-wise? 100%? And that hurts, if some you can use a blog or something like that to get into a site and then pivot from there. But this is like, hey, directly into your database, and it's not any better. People are sort of system administrators aren't doing any triage about what's going to cause real problems. It's just people don't update. Again, nothing too shocking there. SPIP, a French CMS, 65%, a little bit better. Here's something interesting. WordPress. Now, conventional wisdom has been, if you go out there and read, that WordPress has awful security. You'll hear people saying this over and over, oh, I couldn't possibly run WordPress. Their security is dismal. But certainly one thing that their users are doing is absolutely keeping up to date. Remember when I was talking back at the beginning about these very easy to install apps and ease of use? Their WordPress has their famous one-click install and their famous one-click update, and it's really reliable. If you run WordPress, you probably found out that when a new version comes out, you can maybe back up your tables, but you can usually expect the install to work. And I think we see that here. I think that a rabid focus on ease of use and predictability and all that kind of stuff truly does drive user behavior. So anyway, if you're looking for hard numbers to talk about, if we make it 5% easier for our users to apply patches, will we see that, or how far do we have to go to get this kind of up-to-dateness? I really like this spike here as a security person. I love to see people running, and this was the most recent version until right before I did the scan. You can see that they're in the release candidates for 3.0 when I did this scan. But this is great. So based on that, what do you guys think for published known vulnerabilities against WordPress that people are vulnerable? Less than 50%? More than 50%? What's that? 65. Less than 65? More than 65. Tough crowd. So a couple of things could possibly contribute to that. I think helping people update really contributes to that. The other thing is they've had a number of vulnerabilities. They've had some serious problems with actually at one point somebody broke in and tainted some of the code that was set up for release. But they've done a pretty good job of helping people update, telling them to update, making it very obvious in the administrative UI that you need to update, and here's how you do it. So good driving of user behavior. So that's very cool. Good on WordPress for doing that. Good on anybody who makes it easy for their users to stay secure. On the other hand, there is something else that could contribute to this metric, which is WordPress doesn't have any formal security notification policy. All the rest of these ones that I showed you did. You can go to Joomla and look up what are all the Joomla advisories. You can go to Drupal and look up what are all the Drupal advisories. You can't for WordPress. So good on them for one thing, very much bad on them for another. So it could be that there is something more recent than that I have no way of finding out about it. I Googled, I checked some things, but so definitely a story of yes, but no. So if anybody works on WordPress here, come up and chat with me afterwards. I'd love to help get you guys going with that. Certainly as vulnerability researchers, as vulnerability management people, make our jobs so much easier. All right, so just because I had to pick on them a little bit, I said, okay, what about medium vulnerabilities? This is medium based on any of the rating systems out there. So 21.5%. Even if we go down to mediums, I think this is if you are an author on the blog, then somebody can trick you into inserting script. So there's some more significant conditions for this one. But yeah, so that's kind of cool for WordPress. So anyway, hopefully contravening a little bit of conventional wisdom and salvaging their reputation there. I am not paid by WordPress. So version clusters. Obviously, we said we're talking about sets of possibilities. And it makes sense that there are some versions that are going to be more difficult to distinguish. So here is sort of a visualization of that. Any of these lines that are going back and forth mean that when we did these scans, there was a scan that came up that said, hey, I know it's version 1.3.11, 12, 13, 14, 15, or 18, but I can't tell. So that we returned that version set instead of a specific version. So you can see from time to time we get these little groups of versions that get confused. More lines, thicker lines means that happen more often. But even in the worst case scenario, we end up pinning it down to 3, 4 versions. So that's sort of the graph of how accurate we're often going to be for MediaWiki. For Drupal, found more of those, so just sort of thicker lines in general. But you can kind of see this segmentation forming. Don't look at any individual details, just look at where the hemispheres start coming up. SPIP, we can do a pretty good job on that. We generally pin it right down, except for that one cluster over there. But you can see that those are all release candidates, so it's no surprise that we get those confused all the time. So a couple of war stories. Sometimes you see this data and you just have to go digging into the story behind it. This is a WordPress blog that was running an astonishingly out-of-date version. And so I was looking at it, and this is a guy who's got lots of big talk about security and Russian hackers. He's vying for the sanctity of his website with these Russian hackers who keep putting stuff up on there. And I said, well, that's really weird. Fingerprint him. It doesn't show up. But yeah, he's 6 years behind on his updates. So I think he was one of the only people who was that far behind. I was astonished. So some people talk on one side and have skills, but are missing the basics. Here are some people who actually do a pretty cool blog. Like this. Is that you? Okay. So yeah, I was reading this post. I thought it was really interesting, and I said, remote file includes. I seem to recall hearing something about that. So okay, fingerprint them. They're running Drupal 6.12. All right, quick, let's go look up Drupal 6.12. Yeah. Yeah, you guys have got a vulnerability in your site. Go fix it. Sorry, I hope they wouldn't mind being picked on. Some observations. As you saw from that, how it starts off sort of very low at the bottom and then ramps up to that bell curve within the last 3 to 8 versions. People tend to, most of the weight is up there at the top. Most of the weight is within that last 3 to 8 versions. But we've found that for security purposes, that's not good enough. You really need to be in the last 1 or 2 or 3 versions to stay out of those vulnerabilities. We see, as I pointed out, a huge spike at versions provided by package managers and hosting services. So you can't blindly trust those to keep you up to date. There is a possibility some of those were backporting the patches, but not happening in a lot of cases. We can go back and see if it changes the numbers too much. I don't think it will. So, and also improperly removed web apps. Saw this in a number of cases. If a site installed Drupal and then 6 months later decided they wanted to go to Joomla, they would just install the new one right on top of it, replace the index.php and call it good. And so in their vulnerability reports and their scan reports and their audits, they would say, yes, our front-facing web app is up to date, it's at the latest version, entirely forgetting that there is this other thing on there, that the functionality still exists, the database realistically is probably still intact, and you can go hit that code and it will function perfectly fine. It's just that nobody normally sees it. So those are some things that I was able to turn up when you do the app guessing and you say, Joomla and Drupal? That's kind of odd. Net visible test QA sites also saw instances of where the main site would be installed and up to date, and Shodan would turn up QA or staging.example.com. And that site was very much not up to date. So if you are not scanning yourself, if you're not aware of all of the properties and all of the apps that you're exposing to the world, definitely first thing you need to become aware of those. Precision, how do we do on all of these scans, all the machines that we hit? Average versions that we came up with was 3 versions. These couple of things, some Japanese versions of WordPress actually. I didn't have the Japanese files, so that bumps those up. But realistically, if you use BlindElephant either as a standalone tool or if you're building it into as a library into some app of your own, you should generally be able to pin things down to 1 or 2 versions. So that tends to be good enough for our purposes. Speed. I was hoping to not send you out to get a cup of coffee, and we do all right. The average is 6.4 seconds, 6.5 seconds. 95% of scans are done within 95% of fingerprints are done within 10 seconds. Guessing will take you a little bit longer. So how'd we do? We were talking about things that we want in a web application scanner. It's very generic. We use the same code for all apps and plugins. It's very fast. Get you done in under 10 seconds, hopefully. Low resources, that's the average of what we pull down from the remote site. It can be a little bit less or a little bit more. Accurate, 2, 3 versions. Pick up an ID on 98% of sites. I'll figure out what's up with that other site, and we'll get it for sure. Resistant to hardening and banner removal, that was what drove us down the road to go to this technique. So yes, it is absolutely resistant to hardening and banner removal. And then it's very easy to support new apps. An hour or 2 hours, get everything, dump it into a directory, unpack it, and go. So if you have apps that you want to support or help support, by all means. Some source of error, talked about web app incompletely removed. Sometimes that can be a false positive. Partial or manual upgrades, we do okay on catching these. Changed app root, maybe what was going on with that other one. Static hosting, same thing. You can't run this tool directly against Wikipedia because they have everything hosted on, instead of en.wikipedia where we look for it, it's on static.wikipedia, and we can perhaps put in some logic to look at figuring that out. Forked projects. And then here's the last thing that is the Achilles heel of static file fingerprinting, is it's using cryptographic hashes. So if someone systematically made changes to every single static file we wanted to fetch, this technique, as currently implemented, goes away completely. So people don't do it yet. We actually want to make that available. I've got somebody who's interested in this project who will hopefully be committing something to provide that functionality to web administrators to just go ahead and blow BlindElephant out of the water. So there's two sides of this where we are providing tooling on both sides. So it is open source. It's available there now. We're still figuring out the license. It will be an open source license of some point. I think we're going between GPL or LGPL. We'll have that figured out very soon, but you can go there and be able to get the code. So to do some stuff that folks should do, but running a little short on time. So any questions? Oh, sorry, web page. BlindElephant.sourceforge.net, or it should be Googleable now. It's a pretty unique phrase. Just don't type in white elephant.
We have about 5 minutes left. One question?
You mentioned backporting of patches,
yes,
which appliance vendors tend to do. Rather than putting the new version, they'll patch the only bit that's needed for a critical vuln, et cetera, et cetera. And you said that you doubted that much of that was going on, but I wonder how you could justify or sort of qualify that statement. In other words, you might be overestimating the number of vulnerable systems.
Yes, I very much could be overestimating the number of vulnerable systems, and maybe I should back off that and say it's entirely possible that some percent of people are backporting those patches, and so I am over-reporting. And that would be good research to do to follow up on this. So do some of that, or find people who have those hosting providers and check and see if the vulnerable stuff is in place. On a couple of ones, like for the Ubuntu and Debian package managers, I actually went and looked to see if there was any backporting going on, and it wasn't. So I checked some of the package manager side, anecdotally, not statistically, but hosting managers, I didn't hit that as much. Certainly, we can go do that, and I'll rerun these numbers because I'd rather them be sort of more accurate and a little more conservative. That'd be good.
So if you're an appliance vendor and you are backporting just the vulnerability part of upgrades.
Yes, then we have reported you as vulnerable where you are not.
I know this is a bit of security or obscurity, but for those people who are doing that, given the effectiveness of this technique, would you recommend that they change something so that you recognize it, or do they leave it and hope that the guys try the wrong attack?
I think there's the bad guys. In some cases, are doing fingerprinting. In other cases, they're just launching the attack. So this has less utility for the people who just want to go out there and own systems. But if hosting providers want to get really clever and apply that technique of going and making a trivial modification to all those files, that's something they could absolutely do. That would nuke this at the hosting provider level. So I don't have necessarily right now a recommendation on which way they should go. I think the bad guys are just going to launch the exact same attack on every machine that they come across and see what happens. So it's the lowest effort for them. Yeah.
On a practical note, the usefulness of this tool is kind of predicated on the availability of up-to-date signatures. Is there a model yet to put signature sharing in place, et cetera?
Yes, the SVN has signatures in it right now. I'm trying to figure out what the right model is to be able to accept signatures from people who want to contribute. These are actually just pickle files right now, so there is some danger in just freely passing those around. So I want to get some validation on that. And I don't know what the right model is for developing sort of, the standard BlindElephant WordPress data files. We will come up with something. I'm open to any community suggestions, or maybe if there's merging or some kind of voting about this is a really good file. I want to try and keep the fragmentation down, but I do want to get as many people contributing as possible. Does that answer your question? I didn't actually see who.
Yes.
Okay.
Patrick, I've got two questions. One is, did you see any correlation between open source and COTS software? And the second is, have you looked at maybe putting this into a hosted database like SSL Labs?
Funny you mentioned SSL Labs. Actually, Ivan helped me out with some of the getting the hosts to scan. I haven't looked at doing that. I'm not entirely certain where I saw you were going, but if it's a good idea, come up and discuss with me afterwards, because there's lots more places we can go with this. And then the first part of the question was, commercial versus. Didn't really have access to a lot of commercial software, so that's why you saw that these were primarily open source, because that was easy to get to. If anybody wants to help me start creating more fingerprint databases for that commercial stuff, we can do that en masse, or we can start collecting it sort of version by version by version from people that we know who are running those versions. I'm also looking at possibly doing something that will reach out, and if it knows a little bit about an app, it will take a new version, pull the data down, and incorporate that into the database. So, do it the hard way. But we'd much rather do it the easy way if people want to, if people have access to that stuff.
One last question.
Yeah, so it sounds like in order to run this, you would have to have a pretty extensive collection of all the different applications you would potentially want to fingerprint, and then all the other versions. What kind of data storage are you looking at to do that?
So the nice thing is, for anybody who wants to just fingerprint, the data files themselves are 300K, 400K. Very small data files. For anybody who wants to build a table for, like, say, WordPress, every single version was like a gigabyte. But only one person has to have that. If I want to sort of generate up-to-date WordPress versions, I have those on my machine. But not everybody who wants to do fingerprinting has to have that. So it's back end versus front end, really. Does that wrap it up? And then the other thing that I was just reminded about is we've also got on the Qualys community, if you go here, there's we've got some forums and that kind of stuff set up, and if people want to sort of contribute and discuss, this will take you as well to a link to some community that we've set up on Qualys. The code is directly here on BlindElephant. So that's what we got. Thank you very much.